Okay, everyone, today we're going to start on a new slides on one of the issue that a lot of students face, and that is they do not know when they are supposed to use the area under the graph of a speed time or velocity time graph to solve for their kinematics question. This is especially true if the question is all written in words. Let's say the question is written in words that asks you to find the velocity or to find the distance traveled. So when do we need to draw the graph to solve the problem, and when we do not need to do it? So in this subsequent slides, I'm going to look into this. So I divided the problem into two parts. The first concern that students have, which is a very basic concern, is that how do I know that I have to use area under the graph, the speed time graph, and how can I be very sure? Now the second question is what is the difference between something that they learn in primary school and in lower secondary school, which is the formula distance equal to speed times time, okay, and area under the graph. They know that there are the existence of these two formulas to find distance, but they do not know why is it that sometimes their answer using distance equal to speed times time is correct and sometimes it is wrong. So when to use area under the graph and when to use distance equal to speed times time to solve the question. Okay, so I'm going to look at the first part, which is when do we use area under the graph first. Okay, so what I want you to do now for this slide is I want you to look at the three questions that are given here. I want you to read it, and I want you to determine the method or formula to solve the following questions. Alright, you don't actually have to solve it, you just have to roughly tell me the approach. So what I want you to do is to pause the video now. Okay, I believe that you have already solved the three questions. So let me show you the answer. Now in the first case, because the car accelerates or increase in speed from 5 to 20 meters per second in 10 seconds, and you are finding the acceleration, you use the formula A equal to V minus U over T to find A. Straightforward, just a formula method, no graph involved. In the second case, same way, alright, you're given the deceleration, and then you're given the initial velocity. So what's the time taken to go to a rest? You have to use the same formula A equal to V minus U over T. Now in the third case, where the car accelerates from rest to 20 meters per second in 10 seconds, alright, they ask you for the distance traveled, alright, so you must use area under the graph. So can you tell me what is the distinction between these three questions? Okay, if you are watchful enough, you'll realize that in the first two questions, the questions only revolve around velocities, time, and acceleration. Velocity, time, and acceleration. But in the third question, there is a fourth factor, which is distance. Alright, so in a nutshell, if distance is involved in the question, you will have to use area under the graph to solve it. Okay, so this is the answer to part 1 of the problem. So whenever you see a question that requires you to find the distance, or they give you the distance, you're supposed to find the velocity, the deceleration or acceleration, you will have to use area under the graph. So this is the first problem. Now let's look at the second problem. Now you learn in primary school and you learn in lower secondary school, distance is equal to speed times time. Okay, it is like a commandment to you, alright, it has to be this way. But then when you come to Sec 3, you learn that you can actually find the distance traveled using area under the speed time graph. So when you are sitting for an examination, you end up confused. So which one is which? When do I have to use which? So I'm going to give you two questions below. What I want you to do is the same thing. I want you to pause the video and to think about the approach that you will use for question 1 and question 2. Okay, so I believe that you have already solved the question. So I'm going to review the answer to you now. Now in question 1, you straight away use distance equal to speed times time, and the answer is 200 meters. Okay, in question 2, you will have to use area under the graph, and the answer is 20 meters. Now, what is the commonality, what is the difference, beg my pardon, between 1 and 2? So obviously, if you look carefully, you will realize that one is constant speed, the other one is accelerating. So the key difference between the two is, number one, if you are using, if the object is traveling at constant speed, you can use distance equals speed times time. However, if the object is accelerating or decelerating, you have to use area under the graph. Okay, so this is the clear distinction between method 1 and method 2. Now let's move on to simplify the approach a little bit more. So in short, distance equals speed times time can only be used if the speed is constant. However, I would like to add a new point, is that area under the speed time graph is applicable in all situations, including constant speed. So just now you observed that in the first question we use distance equals speed times time. So we are going to relook at the first question again. Okay, you remember this is the first question that was given in the previous slide. That is, the car travels at a constant speed of 10 meters per second for 20 seconds. Find the distance traveled. So obviously, mentally you will already arrive at the answer is 200 meters. Alright, but actually you can use area under the graph to solve for it. Alright, so if you draw the speed time graph, you realize that it's a straight horizontal line, and if you want to find the area under the graph, it's obviously equals to 10 times 20. So you get the same answer of 200 meters. So in short, right, okay, it seems that area under the speed time graph has already replaced distance equal to speed times time in all scenarios. Alright, so what is the best approach? Okay, if no distance is involved, okay, that means the question is always acceleration, speed, and velocity and time, no distance, no displacement. You can use A equal to V minus U over T, and you will always be able to solve it. Now, if distance is involved, okay, the best approach is always use area under the speed time graph, regardless of whether the speed is constant or not. Why? Because area under the speed time graph covers all conditions, so you will not get it wrong. So in a nutshell, I want you to remove that old formula that you have learned in primary school and lower secondary school, which is speed equal distance over time, or distance equals speed times time, and only use area under the graph from now on, and you will be very, very safe. Okay, so however, I would like to put a disclaimer, is that in the future chapters, when you go to energy conversion, you will realize that energy has another method that can be used to solve for distance questions. Alright, when we come to the topic of energy, I will readdress the differences when you can use energy method and when you still have to use area under the speed time graph to solve for a distance question. Alright, so let us do a few questions now. Let's do the first question. Okay, it's a jumper up of the different approach. Okay, so you may pause the video now and try the question. Okay, have you solved it? So first of all, you realize that there is no distance involved. Okay, once there is no distance involved, you do need to use area under the graph. Straight away, it's a simple A equal to V minus U over T, and you solve for it, you get 3 seconds. No issue. Alright, now the second question. Okay, please pause the video also. Okay, so I believe you have solved the question now. So you realize that you have to use area under the graph. Okay, and in this case is because there is distance involved, so you will realize it is a decreasing speed from 20 to 5, and the area on the graph is the area described by a trapezium, and you get 37.5. okay, so last one. Okay, last one, so please pause the video. Okay, once again you realize that there is a distance travel, although it is constant speed, and if you see constant speed you probably will have already multiplied 50 times 10 times 60, but in case you don't understand the difference, always use area under graph and you will be safe. Okay, remember to convert minutes to seconds, so you get 30,000 meters. Okay, so I hope that this clarifies your doubts. Remember what we said just now. When there is distance, area under the graph. When there's no distance, A equal to V minus U over T. And always use area under the graph in all situations pertaining to distance, because it will save you a lot of trouble, especially if you cannot distinguish the difference between constant speed and non-constant speed in the question involved. Okay, so I hope that these few slides has been able to clarify your doubts. Okay, thank you and have a nice day.